All right, good morning, everybody. This is take two. All right, I did about 10 minutes worth of math, and then I realized that I didn't even have a microphone plugged in. Where are you supposed to be getting any of this sound? So I plugged the microphone in. Good morning. I've worked through the first problem of equations with variables on both sides with decimals and fractions. Uh, I've done the first one here for us. We've done minus 2.5d on each side, minus 4 on each side, and then to get rid of the negative 0.5 down here, you do times negative 2. Um, so basically, you can pause the video and copy this work down, and you will get an answer of d equals negative 12. Oh man, what did I say at the beginning? Good morning, good to see you. Oh yeah, that the only expectation of work to be completed is whatever assignment that I'm doing on the videos. That's the only thing you're expected to complete as well. And I actually give you all of the complete answers and work, so you should be able to just submit this homework no problem, especially since I'm giving you all the answers. If you would like to work on it independently, that's fine as well. You know, people were asking me, do I need to watch this video? Not if you can do it on your own. If you can do these assignments on your own, please be my guest. I would be very happy to see you do that. Okay? So there's the first problem. I got it correct. I got a nice little encouraging word from Khan Academy. I accidentally entered positive 12 the first time. I don't know why I forgot to put the negative. So at the end of this lesson, it will say I got 3 out of 4, but we all know. It says that's the right answer. Keep practicing. So, okay, back. So now we got 2/3 B. Oh, this I love this. All right, so 2/3 B. I can't believe I did 10 minutes of math with no microphone. Oh my goodness. 2/3 B plus 5 equals 20 minus B. Okay, we have an equation with variables on this side and on this side. So again, we want to keep whatever's on the first side, get rid of whatever's on the second side. So here we have a minus b. How do we get rid of minus b? Think about it. Pause the video if you need to. To get rid of minus b, you would do plus b, and then plus b. Now when you do plus b, that's really plus 1b, right? So I'll put like a little 1 there. Plus 1b plus 1b. Let's go ahead and do that math on each side. 2/3 b plus 1b, that's 1 2/3 b, plus 5. And then on this side, 1b minus 1b, like these are opposites, so obviously you cross that out, and you're left with simply 20. Okay? Next, we want to get b by itself, but there's these coefficients and constants hanging around. So let's get rid of that constant of 5. How do you get rid of plus 5? Think about that. Pause the video if you need to. Welcome back. You do minus 5. I probably should have given you more time to pause the video, because maybe you just got the answer right away. It's okay. 5 minus 5, gone. And so you're left with 1 2/3 b equals 20 minus 5, that's 15. Okay. And then from here, 1 2/3 b, you can either divide by 1 2/3. Yeah, let's just do that. I want to show you like the most possible ways you can do this. So divide by 1 2/3 and divide by 1 2/3. Now let's see. This is the way I would do it. This would be like the shortest way. So on the first side, you're just going to be left with b, right? 1b. On the second side, 15 divided by 1 2/3. Here's the way I would do it. I would do 15 divided by parentheses. So look at that, 15 divided by parentheses. And in the parentheses, you're going to go 1 2/3. And the way you do that is 1, 1 fraction button 2 fraction button 3. So that right there says 1 2/3, even though it's not, it's not the best. You could also use your calculator. As long as you use parentheses, You should be fine. 15 divided by 1 2/3. What does that say? 9? Yeah, it says 9. Now, if you're curious about this, 1 2/3 is 1.66666. So let's try it with the decimal version, see what happens. I'm going to do 15 divided by 1.666666666. See how I just put a ton of sixes? 15 divided by 1.6666666. All right, here we go. And as you can see, hopefully, it still gets you 9, okay? So we end up getting B equals 9, positive 9. Hopefully that's completely right, because last time I accidentally forgot a negative sign. But no, it should work. There you go. Good work. You got it. 2 more. Let's keep going. Let's keep going. We gotta go fast, all right, guys? Because, again, you can pause this video. You could take it at your own speed, so that's fine with me. Let's go. 9 plus 3.5g. 9 plus 3.5g equals 11 minus 0.5g. Is this viewable? Yes, it is. Okay. That's a little baby equal sign. That's okay, though. Again, variables on both sides. Whatever variable's on the first side, keep it. Whatever variable's on the second side, get rid of that. Negative 0.5g or minus 0.5g. How do you get rid of a minus 0.5g? You do the opposite. Plus 0.5g. Okay? And then same thing on both sides, always, okay? I think there's going to be some easy math here. Let's do it. What are we going to bring down on the first side? We're going to bring down 9 plus 3.5g plus 0.5g. That makes a perfect 4g. Like the 4G network, all right? Next, 11 gets brought down. And then 0.5g, negative 0.5g plus 0.5g are opposites, so they're gone. Now we want to get g by itself on this side. We got a 4 coefficient and a 9 constant. Let's get rid of the constant first, as always. To get rid of this plus 9, we're going to get rid of it by subtracting it, minus 9 on both sides. Okay? 9 minus 9, gone. Bring down 4g. Equals, and then on this side, 11 minus 9. That's a positive 11. I don't know why it looks like a negative. 11 minus 9 is 2. And then final step to get g by itself, to isolate it, is to divide by 4 on both sides. And so we would be left with 1g equals 2/4. Or if you know how to reduce 2/4, you know that's a half. And if you know a half in decimal, you know that's 0.5. I'm going to go with 0.5 because that's like the shortest way to enter the answer. So there we go. Ooh, now we got fourths. Fourths. This is the final question on this assignment, so if you're following along with me, very well. 9/4 y minus 12 equals ... 1/4 y minus 4. 1/4 y minus 4. Variables on both sides on this problem. First side, you're going to keep that variable thing there. Let's get rid of this 1/4 y. How do you get rid of it? Well, you subtract it. I hope you noticed the pattern, by the way. The pattern is this. The first thing you generally do to start isolating a variable is you subtract some stuff. When that final step, when we start dividing, you know, that's saved for the last step. But here, let's just subtract. 9/4 y minus 1/4 y. It's going to be 8/4 y, which hopefully you see that can be simplified. 1/4 y minus 1/4 y, gone. Bring down this negative 4, okay? You always want to bring down the sign that's right before the number. Okay, 8/4 y, that's really just 2y. Right, so I'm just going to rewrite everything. How do I get rid of this? I want to isolate y, so I got to get rid of this 2 coefficient and this minus 12 constant. Again, as always, get rid of the constant first. So get rid of minus 12 by doing what? By adding 12. Adding 12. Let's see what happens. Bring down 2y. Minus 12 plus 12, opposites, so they're gone. Equals negative 4 plus 12. Or if it's easier for you, 12 plus negative 4. 12 minus 4. 12 minus 4 would be 8. So 2y equals 8. 2 times y equals 8, which means that if you divide each side by 2, I don't have any more room, but you could probably just do this math mentally. 2 times 4 would equal 8. So y equals 4. Okay? Y equals 4. So let's enter that. That is the final answer. Hooray. It's going to tell me I got 3 out of 4 because I accidentally left off a negative sign at the beginning. But, you know, that's fine. I'm not mad about it. I'm not mad, I promise. All right. Let's just go in order. I'm just going to go in order, all right? And see, how long have I been doing math here? 11 minutes? We finished one assignment in 11 minutes? Holy moly. All right, good. That's good. Could probably knock out like 2 more right now. That's all I'm going to do, I think, 2 more. All right, unless this is like super easy. The American antelope, pronghorn, and the wildebeest are among the fastest mammals on the planet, particularly at running long distances. Oh, you can't even see the story. Hold on. There you go. Shrink my whiteboard down. Once again, the American antelope and the wildebeest are among the fastest mammals on the planet, particularly at running long distances. The maximum recorded speed for the antelope is 88.5 kilometers per hour, which it can sustain for nearly 1 kilometer. So 1 kilometer, that's like almost a mile. So that's pretty fast. On the other hand, the distance d in kilometers that the wildebeest can run in t hours is given by the equation. Okay, so hold on. Let's write this down. Antelope. That's like a deer. Antelope can run 88.5 kilometers per hour. K/h. That's the way. km/h. That's the way I like to write it. But that's the speed, 88.5. Then the equation of the wildebeest, so I'm going to write wildebeest. I love that name for an animal. It's like wild beast, wildebeest. But they say that its equation is d equals 80.5t. Now, what does that 80.5 mean? Hopefully you remember before we left, when we came up with speeds, when we came up with equations, that right there, that 80.5, that represents the speed or the rate of the wildebeest. So the speed of the wildebeest is 80.5 kilometers km/h. So who has the higher speed, the antelope or the wildebeest? To me, it looks like the antelope because it's got the bigger number, okay? But yeah, so that's what we're comparing is speeds. Yeah, we compared speeds. The American antelope is faster. Cool. Next one. Oh man, I love these problems. I don't even think you need the whiteboard for this one that much, do we? Let's see. I don't think so. All right, it says here the unit rate of change y with respect to x is the amount that y changes for a change of 1 unit in x. Is the unit rate of change of y with respect to x in the equation, let's see what it says, y equals 6.5x, or in the graph below. Wait, hold on. Is the unit rate of change of y with respect to x less in the equation y equals 6.5x, or in the graph below? Which one has a smaller rate of change is what they're saying. So in the equation that they tell us, y equals 6.5x, what is the rate of change? The rate of change is right there in the equation. It is 6.5. Let's look at the rate of change of this graph here, though. So let me see if I can enlarge this graph a little bit. Oh yeah, I can. So as you can see, we got a line here. Hold on, let me erase the wildebeest thing because that's distracting me. But let's see the rate of change in this equation real quick. So in this equation, we got Uh, I see that we have a point at 0, 0. And then where else do we hit a perfect corner? I think I see we hit a perfect corner at the point. God, I wish you could see it. Man, I gotta scroll down a little bit to show you. There we go. Okay, now we can see it. So I believe that this line goes through the point 0, 0 and through 2, 7. So if I go from 0, 0 to 2, 7, the rate of change is equal to, or the slope is equal to, of this line, how much rise and how much run. So hopefully you're at home counting, or you can see just from the graph that you go up 7 units and you go to the side 2 units. Oh, not up. You go to the side 2 units forward. So 7 over 2 is the slope. 7 halves. What is 7 over 2? 7 divided by 2. Well, 7 divided by 2 is 3.5. So you could either show your rate as a fraction or as a decimal, okay? But which one of these is the smaller rate of change? Is it the 6.5 or the 3.5? Well, the 3.5 is the smaller rate of change. So let's look at our options. The unit rates are the same? No. The unit rate is less in the graph? Yeah, I would say so. Because look, it's 3.5. So, yeah, it's definitely less in the graph than in the equation. Okay, cool. Oh my gosh, tables. Let's see. Tables, tables, tables. Roberto is having his house painted. The job takes 3 days, and he pays the painter the same hourly rate every day. The cost of the job is in the chart below. Which of the following equations, where H represents hours worked and P the amount paid in dollars, represent an hourly rate that is greater than the painter's hourly rate? Okay, let's look at the painter's hourly rate. So hopefully you can see this table. Oh my gosh, I keep clicking the wrong thing. Hopefully you can see this table. So on the he gets paid the same amount, the same rate each day. The first day, day 1, he works 5 hours and he gets paid $300. So let's take this $300 and let's split it over the span of 5 hours. Let's see how much money is made in 1 hour. So $300 every 5 hours. If you do 300 divided by 5, let's see, I believe that's 60. And so you would get $60 per 1 hour. I don't know. Here, I'm going to rewrite this fraction because it should be written like nice. $60 per 1 hour, or otherwise known as $60 per hour. That's a pretty good rate for a painter. On the second day, he worked 4 hours, so what? 60 times 4 is 240. That works. And then day 3, he works 6 hours, so 6 times 60, that makes 360. Okay, yeah, he gets paid $60 per hour. So the question is, which of the following equations represents an hourly pay rate that's greater than the painter's pay rate? Painter's pay rate, $60 per hour. Let's look at our options and see which one of these equations has a greater rate than $60 per hour. 6.5, no. 50, no. 65, yes. P equals 70 times H, yes. Both of these equations show a rate that's greater than $60 per hour. Okay, so let's check. Let's select both of those and check. Hooray! Next question. Bamboo is one of the fastest growing plants. A typical growth rate for bamboo is 3 to 10 centimeters per day. Wow. Let's write that down. 3 to 10 centimeters per day. That's how fast bamboo grows. And by the way, bamboo is like what pandas eat. It looks like a giant stick. It's got some leaves on it. So, horrible drawing of bamboo, but pandas eat it, okay? Which of the following equations, where T represents time and L represents length, could be descriptions of the growth of the bamboo plant? Okay, well, the bamboo plant grows 3 to 10 centimeters a day. So which one of these equations has a rate that's between 3 and 10 centimeters per day? Well, 1.1, that's not between 3 and 10. 2.5 centimeters per day? Nope. 7.1 centimeters per day? Yeah, that's between 3 and 10. And 9.3 centimeters per day. Yeah, that also is between 3 and 10. So we're going to check that, and we are correct. Hooray. Okay, cool. Moving on. Can you guys read that story? Yes. I'm going to move the 8th grade math thing, though. Wow, we've been going 20 minutes, and we've got some good progress going. Okay, it says, Raquel takes her pulse in order to find her resting heart rate, measured in beats per minute. She takes it for 3 minutes and makes the following table of the results. We'll assume that Raquel's heart rate is constant over the 3-minute period, which, by the way, in real life, that doesn't happen. Your heart rate is changing like every second. It slows down and speeds up constantly. But anyway, the graph below shows an ideal resting heart rate for someone of Raquel's height, weight, age, and general level of fitness. Wait, I don't see any table. They said that she made a table. Oh, the table's down here. Okay. Hold on. So the question is Raquel's heart rate slower or faster than the heart rate shown on the graph? Okay, well, let's look at this. Let's look at this picture here. If you see the table up here, that's Raquel's heart rate. So I'm going to write Raquel's heart rate is, let's see, well, in 1 minute, it beats 62 times. And in 2 minutes, it beats 124 times. So it looks like per 1 minute, Raquel's heart rate is 62 beats per minute. 62 BPM. By the way, BPM is how we measure the speed of a heart and how we measure the speed of music, if you didn't know that. Music is measured in beats per minute, so that's kind of cool. Let's look at this graph, though. This is like the graph that tells people, that says, like, okay, this is what Raquel's heart rate should be if she's healthy. So let's see. We start at 0, 0, and let's see. Hopefully you found the other corner. The other corner on the graph here is 140 beats in 2 minutes. So let's write that down. On the graph, we have 140 beats per 2 minutes. So what does that equal? 140 beats per 2 minutes. Well, 140 divided by 2 is 70 beats per 1 minute. So 70 BPM. So let's answer the question now that we know this. It says here, is Raquel's heart rate faster or slower than the one on the graph? Well, Raquel is 62 beats per minute. The graph is 70 beats per minute. So that means that Raquel's heart rate is it faster? No, Raquel's heart rate is slower because the number is lower. Okay? Boom. Dude, I'm feeling slightly ill, guys. I'm kind of glad I'm not at school. I gotta say it once again. I am ill right now. It doesn't feel good. It's all right though. Okay. I was worse yesterday. I don't know if you could tell. I was like hanging on for dear life. Okay. The recipe for Jack's famous chili uses 2 teaspoons of red hot chili powder for each cup of tomato sauce. So the rate of this chili is 2 teaspoons per 1 cup of tomato sauce. In fact, let's write this down. Jack's famous chili. I'm just going to write Jack's chili. Jack's chili has 2 teaspoons, so 2 TSP per 1 cup of tomato sauce. Okay? 2 teaspoons of chili per 1 cup of tomato sauce. His rival, Marcia, claims her chili is spicier. She makes chili in large quantities and uses the chart below. Whose chili is spicier? So here's Jack's chili. He's got 2 teaspoons for every cup. Let's see. Marcia, she has, I'm going to make a fraction. So I'm going to do Marcia, what a name. It's hilarious. Marsha's chili has how many teaspoons per how many cups? Well, I'm going to use the second line. I'm going to say 8 teaspoons. 8 teaspoons. So 8 TSP per, what was it, 7 cups? Oh, man, that's awesome, actually. So 8 teaspoons per 7 cups. So which value is greater? I bet you guys can actually answer this right now. So if you, even without using the calculator, Jack's chili, the ratio of chili to tomato is 2 to 1, right? Or like the fraction is 2 over 1. Marsha's chili is 8 over 7. So what's greater? What has a greater amount of chili, a greater rate of chili? 2 over 1, which equals 2, or 8/7, which equals, well, what does 8/7 equal? Like a mixed number. 8/7 means you can make 1 and 1/7, right? So yeah, who has the greater amount of teaspoons of chili per 1 cup? It is Jack. Jack has 2 teaspoons per 1 cup, and Marsha just has 1 and 1/7 teaspoon per cup of tomato sauce. So Jack has that spicier chili, all right? So let's click Jack's and let's move on. Is this my last? This is my last question. Oh my god, these are fast, man. That's kind of cool. Okay. Andre loves to bake, and plum tarts are his specialty. Plums are on sale for $3.25 for 2 pounds at the farmer's market. Let's write that down. Plums at the farmer's market cost $3.25 per 2 pounds. I'm not going to write it like a fraction this time. I just want to show you that you can actually write it as a line. $3.25 per 2 pounds. So if you cut that amount in half, how much do plums cost per 1 pound? Well, let's cut this in half. What's half of $3? $1.50. And what's half of, well, what's approximately half of 25 cents? That would be 12 and a half cents. 12.5 cents. Or if you just round, that's 13 cents, right? So if I cut this in half, 150 plus 13 cents, that would be approximately 163 per pound. You know, if you use a calculator, you're going to get 1.625. So I just rounded. Anyway, at the supermarket, plums are being sold according to the following equation, where P is price in dollars and L is pounds. The equation is P equals 1.75 L, which means that at the supermarket, so at the farmer's market, this is the price at the farmer's market, okay? I'm going to write farmer or farmer's market. Okay? At the supermarket, however, by the way, if you've ever been to a farmer's market, that's a market that's like outside and farmers run it, versus the supermarket, which is more like Walmart. The price at the supermarket for plums is 1.75. It says it right in the equation. So now that we know the rate at both places, where do plums cost less? At the farmer's market or at the supermarket where it's 1.75? The answer is at the farmer's market, because that's the lower price. That's where it costs less. Hooray. 7 out of 7 correct. Boom. You can't stop me, alright? You really can't. Alright, I'm a beast. I'm a beast at math, guys, and so can you. You can also be a beast. As long as you're not letting your brain rot during this little, time that we're having. So we just did rates and proportional relationships. That was fun. Let's see. Solutions to 2 variable equations. I got enough time for one more. Yeah, it's only been 29 minutes, so I'll go one last assignment. Ooh, okay. This is actually a very good one. So it says here, which ordered pair is a solution of this equation? Well, let's see. We just gotta, so you see the 3 options that they give us? This is how you check if the ordered pair is a solution. you put the numbers that are given to you in the correct spot in the equation. So for example, let me write the equation again. So y minus 3 equals 5 times x minus 2. So here you're not going to put a dot 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 down the middle. Here you're just going to take the numbers that they're asking you to check, and you're going to put them in the variable spots. Okay? So the first option says 2 comma 3. So let's try 2 comma 3 real quick. The y value in the point 2 comma 3 is 3. Okay? So I'm going to put 3 minus 3 equals 5. And then the x value in the first option is 2. So I'm going to put 2 and then drop down the minus 2. So let's see what happens. 3 minus 3, 0, equals 5 times 2 minus 2, 0. And 5 times 0 is 0. So is this true right here? 0 equals 5 times 0. If that is true, which it is, then you know that the point 2 comma 3 that we just checked, that point is a solution. Let's see if the other point, 3 comma 2 is a solution. So I'm going to put a little line here and do another set of work. Now in the second point, 3 comma 2, the y value is 2. So we're going to do 2 minus 3 equals 5. And then the value of x in the second option is 3. So I'm going to do 3 minus 2. Let's do the math for this one. I don't think this is going to equal, but let's check. 2 minus 3 is negative 1. And 3 minus 2 is 1. 5 times 1 is 5. And so negative 1 equals 5. That is not true. And so the point 3 comma 2 is not a solution. So it looks like it's only 2 comma 3. So all you got to do is you got to take these numbers right here and you got to put them into the equation and check if it's true. Okay? That's all you got to do. This is what they call plug and chug. I'm not sure if you have ever heard that term, but the term plug and chug just means you're going to take the numbers that are given to you and you're just going to plug them into the equation. Okay? So let's try that again with our, I'm going to write down the ordered pair first. So the ordered pair is 2 comma 4. We are going to input this into the equation 7x minus 5 equals 4y minus 6. Again, we're not going to put a little dotted line down the middle. We're just going to take these numbers and put them into the equation. So the x value 2 goes into here and the y value goes into here. So if you do that, let's rewrite that. 7 times 2 minus 5 equals 4 times 4 minus 6. Let's see if both sides equal. 7 times 2, 14. 14 minus 5, 9. So you get a whole 9 on this side. And on this side, you do 4 times 4 is 16. 16 minus 6 is 10. And we get 9 equals 10, which is not true. So this ordered pair 2 comma 4, not a solution. So we know that the answer is not going to be A, and it's not going to be C, because if the answer isn't 2 comma 4, then it can't be A or C, because 2 comma 4 is in both of those. So by process of elimination, since A and C can't be it, it has to be B. But I'm not going to be lazy. I mean, you could just pick B and you know you will get it right. But I just want to show you how to input these numbers into the equation. Just in case you want to, you're feeling paranoid and you're like, what if none of these answers are correct? I'll show you. Let's try it. 3 goes there, 6 goes into Y. Let's try it. 7 times 3, that's 21, minus 5. 21 minus 5 is, I believe, 16. On this side, we get 4 times 6 minus 6. Oh, man. Did I write this down correctly? Because 4 times 6 is 24, and 24 minus 6 is 18, which is not equal either. So hold on. Let me check this work real quick, just mentally. 14 minus 5 is 9. And 16 minus 6 is 10. Okay. I bet you there's a D option, because none of these three answers are correct. So, oh yeah, there is a D option. It says neither. So good. Oh my god. I hope you didn't pick 3 comma 6, because we just checked both, and I'm glad that we checked both instead of just taking the shortcut, because I wouldn't have noticed that it was wrong. So you choose D, the option neither. Neither of these points work. Hooray. Wow. All right. I'm no longer going to take any shortcuts, because I bet you there's always going to be like a hidden option. Okay. Let's see this one. Let's try the ordered pair 4 comma 5 first. 4 comma 5, and that's going to go into 2x minus 4y equals 6x minus y. Cool. So let's put 4 is the x value, 5 is the y value, 4 is the x value, 5 is the y value. So let's put these numbers into the equation. 2 times 4 minus 4 times 5 equals 6 times 4 minus 5. I don't think this is going to work just at first glance. 2 times 4, 8. 4 times 5, 20. 8 minus 20, I don't know, but it's going to be like negative. I do know. It's negative 12. I don't know why I lied. I know. But it's negative. And then this answer, 6 times 4 is 24. 24 minus 5. You know that's going to be positive. And it's actually positive 19. So these do not equal in the end. So this 4 comma 5 point that we did, no good. No good, okay? So let's try it with 5 comma 4. Okay? Let's try it with 5 comma 4. So the point 5 comma 4, and we're going to put it into the equation 2x plus 4y equals 6x minus y. And let's do the same thing again. 5 goes there, and 5 goes there, and 4 goes here, and 4 goes here. So let's do this again. 2 times 5 plus 4 times 4. We could probably do that math. 2 times 5, 10. 4 times 4, 16. 10 plus 16, say it at home, 26. On this side, though, let's see what happens on this side. 6 times 5 is 30. Minus 4. 30 minus 4 is 26. And hooray, 26 does equal 26. So that means that the ordered pair 5 comma 4, it works. And so we're going to check that. Yay. And then finally, once again, you could always do these on your own if you feel like you understand it. But let's try it. 1 comma 7 is the first ordered pair they ask us to try. And then y equals negative 2x minus 5. This one's going to be pretty easy. The y value is y. The y value is 7, so I do that. And then 1 goes into the x value, so let's do the math. 7 equals negative 2 times 1 minus 5. Let's try it. 7 is just 7. Negative 2 times 1 is negative 2. Negative 2 minus 5, that's like minus 2 minus 5. That's a total of minus 7. And are these two equal? They might look similar, but one's positive, one's negative, so they do not equal. So 1 comma 7 is no good. Okay, let's check the second ordered pair. Let's check the second ordered pair, see if that works. 2 comma negative 7. I have a feeling that this one will work. I just have a feeling. Y equals negative 2x minus 5. Let's try it. The y value is negative 7. The x value is 2. So let's try it. Negative 7 equals, what's negative 2 times, well, let's just do it. Negative 2 times 2 minus 5. We'll see. Negative 2 times 2 is negative 4. Negative 4 minus 5, so minus 4 minus 5. That makes a total of minus 9. So this was closer. The two numbers were definitely closer, but in the end they do not equal. So this point, 2, negative 7, also does not work. I think I just bumped the camera. That's not good. There we go. There we go. So 2, negative 7 does not work. So neither point that we just checked worked. So you're going to click neither, and you're going to check. Okay? And you're done. Show summary. 4 out of 4. I'm so proud of myself. Yeah, that's going to be it for today. So feel free to, again, do these 3 videos. I mean, not these 3 videos. Do these 3 assignments. The answers are right there for you. And watch a video if you want later on, all right? Just keep that mind strong, all right? We'll talk to you later, guys. Stay safe.